everybody, and thank you for coming. This is going to be a talk on getting started in VR and AR development as a student, and we're going to talk a little bit about how we got started into it and the things that the challenges we faced in our time at Core Simulations. So let me start with talking a little bit about myself. My name is Carlos. I forgot my last name apparently. My name is Carlos Felipe Puerta. I'm the lead developer at Core Simulations. I graduated from University of Houston as a computer science major. I have a background as a 2D, 3D, and 3D artist, as well as audio and video editing. I am a self-taught AR and VR Unity developer. And this is my coworker and co-founder, Zale.
Hi, I'm a 16-year-old developer. Oh, that's an old picture. There we go. I'm 16 years old. I've been programming for around 3 years now. I've been using Adobe CC for 4 years as well. But I'm a Unity VR developer. I've also worked in AR kits, and one of my biggest accomplishments as a developer is I have a VR game on Steam. But that kind of game kind of led me on into what I'm doing now with Core Simulations as one of their VR programmers, and the rest is what we're here to talk about.
Okay, so importantly is this next note we're about to talk about is a lot of things we're going to talk about are still being defined. VR as a new technology still has a lot of things that people are discovering. Best practices are not exactly written down in stone yet because technology changes every day. For example, within the next year, we expect to get visual and face tracking for the user. So that'd be another step that you would have to understand and consider into your entire development process. So the next step is we're going to talk a little bit about different levels and different types of VR and AR. So on the VR side, Zale's going to talk a little bit about it.
Yeah. On the lowest level, it's basically a phone in a box. You have the Samsung Gear and the Google Daydream. They have recently gotten controllers that are Bluetooth connect to your phone, but they're not really tracked positionally, just in rotation. But on the next level up, you have the Oculus Rift and the HTC Vive, which are considered computer-level VR, which means they're tracked in 3D space. They have 6 degrees of freedom, which means they can move in any direction, rotate in any way they want. But all the processing power is handled by a computer, which means that they're like the polygon count and the speed and the latency are very low, and you can get things very high quality on these. What's coming out like relatively now and coming soon is the Windows mixed reality headsets. I don't like using the term mixed reality there because they're VR headsets with a camera on the front, but that's their branding, so we kind of just go with it. They're basically the same as the HTC Vive and the Oculus Rift, except they do something called in-out tracking, which, like the Vive and the Rift, they have external sensors that the headsets will pick up the signal from and uses that to figure out where it is. These new things, the mixed reality headsets, have in-out tracking, which means they have cameras that send signals out into the room, and they reuse the data that comes back to figure out where they are and positionally track themselves, which means they really have an infinite level of tracking if they want. They can go between rooms, you can go to new areas and track in an infinitely large space, while the older versions, the Oculus Rift and the HTC Vive, while they're both tethered to a computer, the HTC Vive and the Oculus are much more tethered in the fact that they can only be tracked in the space you set up using these sensors.
So on the opposite side of augmented reality, you have phone-level augmented reality, such as Pokemon Go and Snapchat. These are, while they are considered augmented reality, in my personal mind, they're really low level in the concept that Pokemon Go is little more than your camera running the world and displaying a 3D model over it. On the opposite end is Snapchat with all these face filters and whatnot. That is simply an extension of facial tracking and facial recognition, which is in of itself very fascinating. But AR can go way and beyond that. On the next level up, you had a few years ago, everybody heard about the Google Glass. It's mostly a myth now that's seen in the industry. That was more on you could have a heads-up display similar to what you would think of in video games. You get a data feed in terms of what are you looking at, what data do you need about it, that kind of thing. And then so stepping up past that is the Microsoft HoloLens and Meta 2, which unfortunately I didn't add on here. But these are head-mounted augmented reality devices. These are devices that are going to scan a room for you and through their algorithms calculate what objects are in the room and tell your apps how they can interact with these objects. Another level forward is the Magic Leap. Unfortunately, Magic Leap's more of a myth that everybody's hoping will exist, so I don't know too much about it. So moving forward as a developer, the first thing you're going to come across is what game engine are you going to use? How are you going to go about it? So while there's going to be people that are going to tell you one way is better, the other way is better, there are differences you got to be aware of on the both ends. So the Unreal Engine is generally considered a little prettier, but a little more not as user-friendly, simply because Unity, on the other hand, is free to use, and they don't. I'm sorry, let me start that again. Unity, on the other hand, has a wide user base, and they have been really great about supporting their community. So in Unity, just about any problem you can have or want, you can find on the internet. Somebody's come across it, someone's posted about it. On the opposite side, Unreal is, like I said, prettier, but they hide a lot of their user help behind their paywall. Once you've paid and subscribed to the Unreal Engine, you have access to all their libraries and all the data and all the forums that people have posted throughout the years. On the other end, as a programmer, you should be aware that Unreal Engine uses C++, while the Unity engine uses C#. While the differences are minimal at the end of the day, it's just something to be concerned about.
Also with Unity, for the enterprise, Unity is more of a standard. Unreal is prettier, but as in functionality and processing-wise, Unity is really the standard in any enterprise-type development.
So, the truth is, it really doesn't matter what you use, at least for VR. There are going to be things to consider a little bit more with one engine versus the other. But they can both build for VR. That's the point of you trying to become a developer. But for augmented reality, unfortunately, Unity is your only option. Unreal has not, as I'm aware, done any sort of support for the HoloLens or for ARKit, that kind of thing. Unity has been great with teaming up with Apple, Google, and several other AR development systems to help you developers get started. So next we're going to talk about a little about what your world's going to look like, 3D modeling. So in VR, 3D modeling is going to be one of the biggest things that can make or break what you're doing. Low polygon count is going to be one of the greatest things that's going to matter in your game. So for those that aren't familiar, polygon count refers to your 3D model. Taking, for example, this boot over here. If we were to put it into a VR and model it, we could build it. Each point within the model is considered a vertex. These vertices add up, and they, as your computer reads the data and sends it over to your graphics card, it's going to keep calling the graphics card and draining power, eventually bringing down your performance. So there's ways to go about that to avoid the problem. The first is low polygon count. Your average game model is going to have, in a regular game, upwards of 60 to 80,000 polygons. But in VR, you want to drop that down to maybe a third of that. So 20 to 40, 40 being a far more complex creature or monster, and 20 being your average character. So to circumvent the fact that you have lower polygons, you want to create high quality textures. Textures are going to define how your model looks. And along the same key is the diffuse, the color and texture, as well as height maps. So the height maps are going to be what makes it feel like you're looking at a carpet or you're looking at this surface that has bumps on it. But like with the polygons, you have to be aware that these things call on your GPU, and if you overuse and if too high resolution, it can drain your GPU and drop the FPS. So along the same concept is for 3D modeling.
For a lot of people may not know this, you may know this. There's something called the Uncanny Valley, which is basically very simple. When you're creating a person or a character artificially, there is a limit to how real they can look, and then it drops, which is best described here like this. This toaster is not weird. The second one, it's kind of strange, but it's fine. The third one, it's getting there, but it's not too bad. The next one, it doesn't feel right. But the thing is, with game development right now, no one can get past that upwards hill, because past there, it's perfect. And you can't, right now, we can't perfectly recreate anything artificially. So that's why and especially in VR, because you're immersed, you're in the environment, you're looking face to face with this person. While in like Mass Effect, that's an extreme example, most of the character models look pretty good because they're not up to face with them. In VR, it's a much higher slope. It's very hard to get around that because it feels like a real person to you, so even more things will look so wrong. That's why most things in VR look more like Bender. But one of the biggest ways you get around it is just change proportions. Staying away from humans is always a good sign. And if you have to go for a human, cartoon is always better than ultra realism. In VR, ultra realism does not look good because the Uncanny Valley always proves that it's a limit for how real it can look. So getting far away from it as possible is really one of the best options in VR. And on another note, this is something more technical, but VR is heavy on your computer. A lot of the biggest problems with VR right now is how much your computer costs, and there's a very good reasons. One, VR has to run at 90 frames a second, which if you know what that means, it means it renders it so many times. It renders the entire scene so many times a second. And most games, 30 and 60 is pretty much good, and that's why most consoles and laptops can run pretty good, can run games pretty well. VR has to run 90 frames a second, which is a third more than the rest, and consistently. Because if it doesn't, it can cause sickness, it can cause a lot of really bad problems. So keeping everything lower means keeping that 90 frames a second, which means your people won't get sick. But an even larger issue with the frames is multi-screen rendering. There are 2 screens. It means you have to render the entire scene twice. So that 90 frames is more like 180. It has to run everything twice for both screens. And you can imagine how draining that is. And that's one of the reasons the polygons have to stay low. Everything is so much lower than regular games because it's a higher FPS consistently twice. But people forget this when they're talking about VR. VR itself, actually running the headset and everything, is draining on the computer. This thing has to calculate from just sensor data from IR light where it is in a 3D environment, which is draining in itself. So you have to remember, your game is not the only thing happening here. Steam VR or Oculus or whatever engine you're using to actually run the VR is draining the computer itself. So you can go, well, this thing just works. Well, what if the tracking gets bad for a second and has a spike performance? That means it's taking away from your game because VR itself takes precedence over your game.
Actually, I'm going to go back to that in a second. Oh. So, talking about that same concept, what a lot of AAA companies will do is they'll have engineers in-house who will do all the math calculations. They'll tell you how many polygons can you run, how many calls to the GPU can you do. This kind of thing is something that, while I'm not personally experienced with, is something these AAA companies are taking into account. They have people they're paying just to do this math for them, just to see how far they can push their tech. So moving on to a little bit about the AR tools. So these are things that for you as a developer, that you can use that are all these, as far as I understand, are free to use. I guess except for the HoloLens, you gotta buy it. But the point is, these are all the tools to learn. This is all online. There's literally dozens and dozens of YouTube tutorials. As a programmer at this university, I feel like the university didn't, the game design programs here didn't give me the tools I really needed to start. So I just dove into YouTube. I dove into the Google forums. Whatever the internet had to offer is the best place to learn.
Just go on in.
Come on in. So let me talk a little bit about each one of these things. So Vuforia is your common image recognition, in that, similar to here, you have an image and the software will run that image back to the servers online, register it across read it with the image you've registered, and play back the models that you programmed to start with that. So with this example, they see the image and the tea kettle pops up as a result. And on the opposite end, you have it's called simultaneous localization and mapping, or SLAM. So SLAM, or otherwise known as computer vision. This is the process of your computer or headset scanning the area and determining what is in the area, and being able to use that across different applications.
For ARKit and ARCore, those are the mobile AR. Unlike Snapchat or Pokemon Go, those are doing the same thing as the SLAM, but differently. Instead of scanning an entire room, the phone will actually find flat planes and uses location of the phone and its gyroscopic stuff, and even sometimes with ARKit, it actually uses your GPS on your phone to figure out where it is in the space and figure out where those flat planes are, which can then placing on top of them, kind of getting away from Vuforia's image recognition. It's actually recognizing planes on the ground, like tables or the actual ground.
So continuing, is an important part of VR and AR is how you interact with the world. Each kind of software and technology uses a different method. The HoloLens likes to track where you're looking at, how you're looking at it, and you can and interacts with certain things such as gestures, hand motions, as well as your voice. Unfortunately, HoloLens is currently limited by 2 gestures, but with the combination of a Microsoft Kinect, you can expand those gestures to literally whatever you want. On the VR side of things, there's kind of several options at the moment. There's the controllers that are standard now with both headsets, with the Oculus and the Vive. But on the more advanced side, there's the, oh my god, is it Leap Motion or Magic Leap?
Leap Motion.
Leap Motion, okay, and I'm backwards for a second. Leap Motion, a special bit of tech that tracks hands very effectively, similar to how the Kinect does your body tracking. And when combined with VR, you can get very, very real, very nice grabbing motions in the world, being able to interact with the things around you. There's more technology coming out. I unfortunately put pictures of it, but for those of you unaware, the HTC is coming out with a new type of controller called the Knuckles. Similar to these top right ones, that is right? Yeah, top right. These controllers have the buttons and that kind of interface, but they're attached to your hands via a strap, so that when you let go of the controller's still in your hand. But in the game world, you've let go of whatever object you're actually holding, giving you that same type of feeling of immersion that the Leap Motion hopes to give.
With the Knuckles as well, they use that same letting go and releasing technique to actually use capacitive sensors like on the Oculus Touch to actually figure out if individual hands, how far away they are from the actual thing, giving it kind of hacked finger tracking, kind of like the Leap Motion, in a less precise method, but still giving you that individual finger control so you can grab things or only point with one finger, or even, the magic bird.
Okay, so are there any questions?